Alright, hello all. What we're going to be doing in this video is solving inequalities. We've been solving equations, now it's time to solve inequalities. That's why you see a less than symbol here. So our work will be done with less than, greater than, less than or equal to, or greater than and equal to. Alright, so the directions are solve, sketch the solution on a number line. Alright, let's identify what we have here. We have variables on both sides of the equation, or the inequality, so we must gather up the variables on one side of the inequality, numbers on the other, solve from there, and then sketch the solution on a number line. Alright, so it looks like I'm probably going to want to subtract 2x from both sides of this inequality. If you're comfortable not doing this work, that's absolutely fine. You can skip what I just did there and just come right down to this line right here. Let's subtract a 7. The result is 2x is less than negative 4. Alright, one thing that you might want to watch out for is when you do divide or multiply by a negative number in an inequality, you have to reverse the symbol. But for this particular problem, we're dividing by a positive number, 2, so we don't have to reverse the inequality symbol. So we're looking for all x values that are less than negative 2. And what that means for your original problem is, as long as you choose x that's less than negative 2, a number that's less than negative 2, and you put it in for this x and this x, the result would mean that this value would be less than the one that's on the right-hand side. Alright, so sketching the solution on a number line is relatively easy. Just put negative 2 on your number line. Now if we put an open circle here, that means that we don't want to include negative 2, and that coincides with the less than. If I filled the circle in, that would mean that I would have seen an or equal to underneath the less than symbol. But it's not there, so we have the open circle. Alright, for this particular inequality, we have a little more work to do. Initially, we need to distribute the 2 through the parentheses. The result is 2 minus 2x. And then we're going to proceed the way we did in the previous example. You don't have to put everything on the left-hand side of the inequality. I noticed that 3x is positive, and if I were to add a 2x to both sides, if I added 2x over here, I would get 5x, keeping that term positive, which is kind of a target for me. Let's subtract 7, so I'm going to keep the 5x over here, keep the symbol in the right direction, the correct direction that it was previously. Subtract 5, so I end up with negative 5. Now to isolate x, we're going to divide both sides by 5. Notice that I'm dividing by a positive number, not a negative number, so the inequality is not reversed. So all x values that are greater than negative 1, I'm going to read from the right. I start with the x, so I read from the right. So all x values greater than negative 1. If I wanted to put the variable x on the left, then I'm going to have to reverse the symbol just because I'm trading sides. The number line is easy. Indicate negative 1, open circle. Greater than negative 1 would mean any number that's greater than negative 1, when put in for this x, and the computations were done, would make the left side of the inequality less in value than the right side. Okay, let's just kind of ramp it up a little bit here. Okay, in this particular problem right here, this inequality, we have a fraction. So this is what we would call a rational. It's a rational inequality. It might be best if we were to clear all the fractions. So noticing that if I multiplied everything by 4, I would get all terms without a fraction. That might be a good thing to work with. So what we're going to be doing is multiplying every single term in this inequality by 4. So in doing so, Multiplying by 4 would cancel this 4, but 6 gets multiplied by 4, etc. Remember, I'm multiplying by a positive 4, so I wouldn't have to reverse the inequality. All right. I think I'll subtract a 3x and bring it over here to this side. So that leaves negative 24. 4x minus 3x would just result in x, and I still have the minus 28, but I will add 28 to both sides to isolate x. Adding 28 to negative 24 results in 4. I'm going to write it with the x on the left-hand side. So all x is greater than or equal to 4. Here's your closed circle. Any x value that's a number that's bigger than 4 when put into the original problem would make us have a true statement, where the left side would be a number that's less than or equal to the right side of the inequality. Okay, so solving inequalities. Let's look at a few more examples. Okay, this is what we call a repeated inequality or a compound inequality, because there's more than one inequality. We're looking for a value of x that when plugged in here, okay, would keep us between numbers 1 and 9. So, oh joy, basically what we have here is we have two problems in one. So let's isolate this x. So I'm going to subtract a 3, but I need to subtract a 3 from both the 1 and the 9. We can do our work within this one problem. So the result is negative 2 less than or equal to 2x less than or equal to 6. Let's divide all by by 2 and 2 here. The result is negative 1 less than or equal to x less than or equal to 3. Alright, so this is just saying any number that is greater than or equal to negative 1 and less than or equal to 3, okay, when plugged in here for this x, would allow us to stay between the numbers 1 and 9. Alright, how do we graph this? Well, put in order, negative 1, 3, both would be a closed circle, and that number x we have to choose has to be in between those two. We're going to look at another repeated or compound inequality. Notice that in this inequality we have less than or equal to, but this one is not closed. It's what we call open. It's just less than. Our variable x falls in between the inequalities, so we have some work to do in here so that we can proceed as we did in example 4. Alright, distributing the negative 3. We'll do a little cleanup. 1 plus 6 is 7, so I have negative 3x plus 7 less than 13. So now we're at a point like we were at example 4, so let's subtract a 7 from both negative 8 and 13. Because it's two problems in one. Those would cancel, bring down negative 3x, perform the computations, negative 15. The result here is 6. Okay, now we're going to divide by negative 3. Multiplying or dividing by a negative number is going to reverse the inequality. So we're going to have x. This will change to greater than. This will change to greater than or equal to. Computations give 5. Computations give negative 2. So if you were to interpret this inequality, think about what it's saying. X has got to be less than or equal to 5, but greater than negative 2. A number that is greater than negative 2, but less than or equal to 5. If you wanted to, you could put it in order, smallest to biggest, put the negative 2 on the left, and the 5 on the right. If that helps you in sketching the solution on a number line, then you might want to go ahead and do that. -2 is open, 5 is closed, x is between these values, so we connect. Alright, let's look at another example. Alright, so the quantity 2x minus 3 divided by 3 has to be bigger than -4 and 4. And what values for x would allow us to be in that target range? Well, I think it was in example 3 we wanted to get rid of the fraction, so let's go ahead and take care of that. Multiplying everything by 3, positive 3, no reversal of inequality symbols, would be the way that we'd want to get rid of this fraction. So multiply everything by 3. And now we just proceed. Add a 3. Divide by positive 2, no reversal of inequality symbols. So x must be bigger than -4.5. That's what the value is here, -4.5. Must be greater than -4.5, but less than 15 halves, which is about 7.5. Ooh, that's bad. Both open circles, x is between those values, we connect. Okay, that shows our solution set. So that's all we're doing in this video, is solving inequalities and then sketching our solution on a real number line.